Okay, I'm just going to show a little bit of what I'm doing here. I made a jig out of melamine board. The reason I use this here is because the smooth finish, it's going to be easier to take these sections apart and have the cast nice and clean. I also waxed it. The bottom here, you can tell I put some fiberglass tape. I used the brass bolts that they use to hold the toilet tank to the toilet itself, and I had to remove the coating on the copper wire. I used a torch because it's high temperature stuff, so I torched. I burnt off the end of the wire, this coating, and then I wrapped it around, and I used silver solder to solder it on. And again, I used the torch to do it because silver solder, it takes about 430 degrees roughly to melt. So it's a high temperature, very excellent conductor material, brass, copper, silver. I mean, you can't get better than that. Now, these are 9 coils. And these coils, I decided to wrap, initially I had wrapped one prototype here. This is the drawing I used to create my, the plans for this unit. And I started off with the tracing where all my magnets were going to be, and this was the first coil I made. And I was a little unalert when I was doing this because the magnets are every 30 degrees. Because we got 12 of them. The 30 times 12 is 360, whereas the coils are 40 degrees apart because we got 9 coils. 9 times 40 is 36. So when I did it, I put it in the wrong lines. I put it inside the lines where the magnet should have been, and instead I should have put it, let's say, these lines here, the orange lines, which are 40 degrees apart. Which means I had a lot more room to do all this. So I decided this one here, you can tell by the quality, I made myself a nice jig, and they're very tightly wound, you know. And I used the crazy glue in between. Crazy glue, very good stuff that will keep the coil together. So this is like initially what I made, but then I changed it, and instead of making this one had 6 times 8, 48 windings, I decided to go, I had more room, so I decided to go 6 times 10, so it's a more thin coil but larger, and I got an extra like 12 windings per coil. So going back here, by doing that, I'm able to squeeze more coils, but a lower profile. And the profile is very important because the thinner the coil, the closer I can get the magnets, the thinner the coils and the stator itself when it's cast, the closer the magnets will be to each other. And of course, the closer the magnets, the inversely proportional the strength of them. As they get closer, they get extremely powerful. So this stator is going to be 5/8 thick, 625 thou. When I finish the pour, because that's how thick the melamine center board is. The other ones are 3/4 for strength, and this here underneath all my workshop is another board similar to this, and again it's the white finish, so it's not going to stick. This is the cover that's going to go here, and I waxed it. I used car wax on this surface. I used a Teflon tape around the perimeter so that it should be easier to come apart. Now I'm at another stage, is that on the center of my rotors, I'm making a fan out of a stainless steel pot, but to ensure that this thing is well cooled, because heat drops the efficiency very quickly. The hotter it gets, the efficiency drops. You got more resistance, and so I want to keep this thing as cool as possible. So now I've gone one step further, and I've made this this coil. Well, coil. It's a cooling tube. It's copper tube that we use to hook up the dishwashers or other units of small flow. It's a 3/8 copper pipe, the malleable one. So I kind of made it shape to go close to the coils, and it snaps right in here, like that. And the ends of it, I soldered on pipe thread. Sorry, it's not pipe thread. It's regular thread. It uses one of those compression joints at the end, but I don't plan to use a compression joint. I'm going to run this through a radiator, and I'm going to have a separate fan. As the wind turns my big generator, I'm also going to have another separate little fan turning my water pump that's going to pump antifreeze through this. Because of the cold winters here, we're in Canada, and I'm building this thing to last many years. I decided I'm going to put antifreeze inside a radiator because the winters are cold, but the summers are extremely hot. And this thing's going to be like on a flat roof where the temperature during the day in the summer could easily hit 150 degrees. So that's where I am roughly over here. Okay, so I'll let go for a bit, and I'll continue with some more footage as I advance the project more.